3B, determining the axis of symmetry in our quadratics. Okay, we have quadratic equations. We are used to seeing them in this format. This is general form. General form is always ax squared plus bx plus c equals 0. We always find our equations in that format. Right now, every single one of those is in that format. If we want to solve it, we have multiple ways to solve it. We can factor to solve it. We could put it into our y equals. So we could factor. We could put it into the y equals of our calculator. Okay, and then we could go second trace, find the zeros. Okay, the zeros. Those are our x-intercepts. Those are the x-intercepts. Okay, we can find those. Remember, when we're trying to solve it, we're trying to find out what the x-intercepts are. Okay, what digit will x become? Now remember, what digit is x to make it equal to 0? Okay, because it's if it's a factor or solution, that means it's a 0. How come? Because when we graph it, we remember, any number along this line, doesn't matter what the x numbers, it's called a 0 because the y number is 0. Y is 0 on the x-axis. That's why it's called finding the zeros. Okay? Okay, the factored form, if you chose to factor them, would be this. X plus 3, x minus 2 equals 0. Now pull them out of brackets. X equals negative 3, x equals positive 2. If you actually did your graphing, you would have found negative 3 and 2 on your graph. Okay? Down here, doing your diamonds, we're going to have negative 30 and adding to 7. What's negative 30 adding to 7 going to give us? 10 and negative 3. So we're going to divide the 10 by 5, negative 3 by 1. So we're going to have 5x minus 3, and we're going to have x plus 2 equals 0. So x is going to be equal to 3 over 5, which is 0.6, and x equals negative 2. Okay, so 3 over 5 or negative 2. Again, 3 over 5 is 0.6. Nope. When it's negative, you take it off the here, right? So this could also be said 0.6. Okay? So that's the first two on the left. Okay, let's take a look at the next two. We've got x and then x minus 9 equals 0. So that means x equals 0. That's what this guy gives us. And x equals positive 9. That's what that guy gives us. So 0 and positive 9. If you did it by graphing, you would find exactly the same thing. 0 and positive 9. Now, the one on the right-hand side here. What do you notice about 4 and 49? They're both perfect squares, aren't they? So if I do this, and I open two brackets, I'm going to have 2x minus 7 and 2x minus 7 equals 0. Now, that means it's only touching once. If you graph it, you got the same thing. It only touched once, and it did this on top of this number right here. What was that number in your calculator? You got 3.5, right? Yep. Well, take a look. When I take him out of the brackets, it becomes 7 over 2. What's 7 over 2? 3.5 all day long, okay? So x equals 3.5. It only touches once there. Now we're going to talk about completing the form, now doing it in factored form. Now, again, you guys did most of it in graphing, okay? I showed you in factored form on the other side. So we did it by graphing the first time when you solved them by yourself. Now by factored form. So here we go. Factored form, just like what I showed you on the board earlier. We've got x plus 3 and x minus 2. Over here we had x and x minus 9. Over here I had a 5x minus 3 and an x plus 2. And over here I had a 2x minus 7 and a 2x minus 7. That's what we found out from the other page. Okay, so again, let's write our x-intercepts. We get negative 3 and 2, 0 and 9. Here we get 3 over 5, which is 0.6. And negative 2. And over here we get 7 over 2 or 3.5, whichever you prefer. Okay? All right. Now what we're going to do, it says find the equation of the axis of symmetry. Well, what we do here, if we take a look at the bottom, it says the axis of symmetry is always the midpoint. Midpoint means the middle of our x-intercepts. So it's right in between both of our x-intercepts. Okay? Always, always. So there's an equation to solve that distance. We can say you take the first x-intercept, subtract the second one, and then divide by 2. Okay? So it's always the first one, subtract the second one, divide by 2. Now, how do you know which one to subtract? It's always take the largest number, subtract the smallest number. Okay? So it's always largest, subtract smallest. So here, I have a 2. So I'm going to go 2, subtract negative 3, all divided by 2. The largest digit here is a 2 versus negative 3. Okay?
Subtract negative 3 or just 2?
It's 2 subtract negative 3. This guy's a negative. So you're always subtracting. Okay? It's always subtracting, and then if the other guy's a negative, you gotta put the negative in. Okay? So you get 5 divided by 2. That's going to give us 2.5. So I know on the graph, at 2.5 on x, I can chop that sucker in half. Okay? That's what it's telling me. Over here, I'm going to take 9, subtract 0, divide by 2. That's just 9 divided by 2. That's going to give me 4.5. So at 4.5, I can chop that graph in half. Over here, who's largest? 3 over 5 is largest. So I'm going to use my decimal. So I've got 0.6, subtract negative 2, divided by 2. Okay? What does that one give us? 1.3? Yeah, it's 1.3.
I don't know how to get 1.3. It's 5.
Okay, so that guy's going to give us 1.3. Okay, over here, we're going to take 7 over 2. What's that?
Leave it at 3.5.
Yeah. Yeah, it's just 7 over 2, or that. Divided by 2, or 3.5. Divided by 2.
So it's 1.7.
So it's 1.75, yeah. 1.75. Now, how come? We've got 2 of the same ones here, right? It's only one of them. If we had 2 different numbers, it wouldn't be would be just fine. It'd be the same. But here, I need a second intercept. So what I'm going to do, I'm taking my 7.2 or my 3.5, and I'm subtracting nothing. How come I'm subtracting nothing? Because you only have one x-intercept there. Okay, so it's x-intercept 1, subtracting x-intercept 2. But it's always your big one, subtract the small one. So here, I only have one of them. So you just have to go subtract 0, which gives you itself. So 3.5 divided by 2 is 1.75. Okay, that's our axis of symmetry. Moving on, let's take a look. I want you guys to try and fill this guy out exact same way. Please analyze your quadratics, and then we're going to talk about a few more examples of axis of symmetry. Okay, take a look at these ones. You tried them for a few minutes. Let's get them together. First one in factored form. If you do the diamond on him, what multiplies to 3 and adds to 4? Only 3 and 1. So with our diamond, we always open 2 sets of brackets. Always, always. X goes at the front. And whatever the wings of our diamond are, go at the back of them. So we do the diamond on this guy. We have a 3 here and a 4 here. We get 3 and 1. So that means 3 and 1 with the back of our brackets. That's how we do that. Now, since it's positive in the middle and positive on the end, they're both pluses in the middle. Okay, if there's some subtractions there or negatives, we'd have to do that a little differently. Okay, direction of opening. You've just seen this graph did this. So what letter does that look like? The letter U, so it goes up. Okay, this guy goes up. When you did your vertex, you're going to find your second trace minimum point. You would have found a minimum point. So we would have got -2, comma, negative or positive 1?
Negative.
Negative 1, they're both negative. Okay. Now, before I go any further, I know that vertex is going to help me with two other things. I'm going to go through and put those two other things in with that vertex. So the vertex is always going to help me with the axis of symmetry, and it's always going to help me with my range. Always, always. So the minute you do your vertex, you can always do those two things right next. What letter does the word axis have in it? X or Y? It's got X. So that means it's the X number of your vertex. So you're going to say X equals -2. And yes, you must say X equals. Okay, so write X equals -2. In your range, because you've got a minimum, we have to say that Y must be bigger than or touching. And now we use the number that we found in our vertex. What's our Y value of the vertex I'm going to use here? -1. Good. Then we use our comma, Y-E-R. Okay, that yer. Okay, your little pirate sound there. Yeah, you should have your fancy bracelets. So you should have your bracelets doing this and your bracelets doing that.
Wait, do you
Okay.
have to have that?
In these charts, no. If it was a problem-solving question, you need to put your braces. Okay? All right. Domain. Always for quadratics. What is domain? XER. Good. All right. There's one more thing I can find out without having to go to my calculator. X-intercept or Y-intercept. Which one can I find out just from the equation? The Y-intercept. Now, up here, if I look up here, which one of those tells me it's my Y-intercept? The 3, the guy without a variable. It's always that one. Now, we're going to write it as a coordinate point. So what is X along that line? 0. So it's going to be 0, 3. There's your Y-intercept. Now, my X-intercepts, I'm going to have two of them. It's going to be a number, comma, 0, and a number, comma, 0. So your X-intercepts are written backwards that way. Y is 0, and X has a number. Now, if I figured out my X-intercepts, I find one of them lands at -3, and the other one lands at -1. And that's how we would write those.
You have to write it in brackets.
Okay? They should be written as a coordinate point, just like your Y-intercept. Absolutely, yep. Because if I just wrote this, if I wrote X equals -3 and -1, what does that look like to you? If I did this, it's all of a sudden a coordinate pair. If you write them together like that, it confuses everybody.
But what if you do X equals -1 and X equals?
That would be fine. Yeah, if you said X equals, that's totally fine. Okay, let's take a look at the second one. Did everybody get a chance to finish that second one? Okay, factored form. We do the diamond on this guy. We're going to get 2x minus 3 and x plus 2. Now everyone's wondering where the heck those numbers come from. All right. We have -12 here, +1. How come it's different? +1 in front of our x. That's our b value. What multiplies to 12 and adds to 1? 4 and 3. We need -3 +4 to give us a +1 down here when we add them. Now we've got to divide one of them by 2, one of them by 1, because that's what starts our brackets. How come that starts our brackets? Because I always have to factor the a value, the guy in front of x squared. You have to factor him first. So he goes into the brackets, as we all know. Okay? And that's who I factor by. All right. Direction of the opening, this guy is also going up. Vertex on this one is going to give us -0.25 and -6.125. Again, it's coordinate points, so it must be in brackets. All right, now from our axis of symmetry, let's go down again. We're going to now do our axis of symmetry and our range. So we know how to do those things the minute we have a vertex. So, axis of symmetry, x has to be equal to our x number, -0.25. Our range, since it's going up, y must be bigger than our touching, -6.125, comma, y-e-r, funky braces. Okay, and as we all know, xer doesn't change, and it was a minimum point. Minimum point, how come? Because it was one of these U shapes. Okay, it's a U shape. It goes down low, turns around, and goes back up. The y-intercept found from our equation, -6. 0, -6. Over here, I'm going to have something, comma 0, and something, comma 0. When you figure out your x-intercepts, you're going to get 3 over 2, or 1.5, and -2. And again, you could have said x equals 1.5, x equals -2. Okay, check your work, see how you did. This concludes lesson 3B of Axis of Symmetry.